it's all yours.
Perfect. Thank you so much for the introduction. So my name is Juan Herrera, and I'm going to be talking here about my paper, Taste Does Not Endure, Network Science Dynamics of Food Recipes from 1977 to 2017. So let's talk about the title of the paper. Does tastes change over time? That is my main question that I want to answer here. Um, for that, I use a case study, which is Colombia, my home country. And then I am going to be using a methodology, which is network science. I'm going to provide the historical context very, very roughly of Colombia between this time frame. And I'm going to explain why I chose this time frame in particular. Then we're going to be talking about the findings. I'm going to be spending most of the time in the methodological part, showing the examples. This is a methodology that is relatively computational, draws from statistics, from data science, from physics, and from computational social science. So I'm going to try to make it as visual as possible without that many mathematics or anything, so it's easier to understand. And please feel free to interrupt me if you have any questions, especially in the methodology part. And then I'm going to show the findings at the network level. So basically all the cuisine, how the ingredients interact with each other. Then I'm going to be talking about two case studies, sweeteners and animal proteins. And then I'm going to move to the conclusion. So does tastes change over time? This is a big question that mostly in qualitative research we have shown, and many studies have shown that it does. Sydney means sweetness and power is probably one of those examples that is very famous, has a broad reach, but there are multiple studies for, you name it, every cuisine, every ingredient that show that change those, the taste does change over time. It does take time. And sometimes changes occur rapidly, sometimes it occurs slowly, but it does change. Unfortunately, in quantitative research, there are three difficulties that have prevented them from addressing this particular question. So the most prevalent is that it tends to neglect longitudinal research due to the difficulty of acquiring historical data. Most quantitative research that has been done on understanding changes in food consumption and taste are done with one shot of data, especially data sets very large from internet recipes. There's a whole body of research I have published on that. Then the other part is that they usually try to model recipe evolution and food studies with just one mathematical model, and it doesn't give that much room to explain the changes in detail. So because it favors mathematical explanation and it falls short of explaining the historical processes and broader socio-economic changes. So that's the need for the literature. So for a historical context, Colombia is a country located in South America in the top south west. It doesn't have traditional seasons as it is located right on the equator. It does have dry, wet season, but it doesn't have a proper winter, which is important to consider when we're going to be analyzing the changes. There are 5 main regions in Colombia. They are not very well connected because of infrastructure and mountains. Basically, 2 or 3 of the regions are well connected, and 2 regions, Amazonian and Pacific coast, are quite disconnected. The most important part here, why did I choose this period? It used to be a closed economy, pre-Washington consensus, which was in 1989. It slowly opened to trade after 1991, when the country decided that they wanted to basically join the Washington consensus. It took quite some time. As an example, in 2012, it signed a free trade agreement with the USA. Important cultural background, Catholic traditions shape food culture. We're going to see an example of this when we look at animal proteins. And it has some social unrest. So there's armed conflicts. In the past decades, chefs also have taken a role in using cuisine as a means of inclusion, trying to source ingredients from different regions and trying to showcase them to be able to provide opportunities for people who are in regions that are not very well connected. So that was the spirit of the study, what guided me to do it. How can I approach this question? By using historical sources that basically correspond with that. So I went to the archives. I looked at different magazines or places that published food recipes. So I could approximate change using food recipes. Why food recipes? Because they provide me with quite a breadth of information that can approximate taste. It also provides me with connections because I know which recipes, which ingredients, so I can look at how ingredient usage changes over time. Recipes come with some biases. They are aspirational. They omit simple preparations, boiled water, hard-boiled eggs, etc. They might have never been used by readers. So a recipe may have been published, nobody used it, so it's biased. It also has a bias towards the elites. It's written, you need to have money to access the recipe, less so in terms of the internet, but still they reflect taste of the elites. There are digital humanities tools such as network science that can be used to study large recipe collections. So with this in mind, I went to the archives and then I tried to find which magazine should I use, which source of information can I use to answer this question. So I did random selection of sources, pre and post 1991, and then Revista Carousel emerged as being the most consistently published one. It published every other Thursday. In the past 10 years, it changed to every Thursday and then every other Thursday again. But roughly, it has consistently published recipes throughout this period. I'm going to show the statistics afterwards. So the potential readership of these magazines is also one of the largest in Colombia. The estimates for 2012 and 2013 have roughly 800,000 copies published nationally, which is equivalent to 1.5% of the total Colombian population, or if I assume 4 readers per magazine, close to 6%. The other thing that is important is that it's relatively inexpensive to procure, as you don't need to pay for the magazine itself. It comes with the main newspaper by main, I mean most widely read, which is periodically. So it comes bundled with it for free with it. So how do this source looks like? I have here a selection. I'm going to go from the most recent to the oldest, and we're going to see the type of sources that there are, the recipes that are published there. So we have recipes from all over the world. They are not necessarily Colombian recipes. We have recipes that are sourced from chefs in restaurants, that are sourced from famous people, like even people from the jet set. They ask them for recipes. We also have commercial recipes such as Nestle, Knorr, etc. have published their recipes there. So this is one example of one that is a commercial recipe. So here we're going back in time, which you can kind of tell by the type of print, etc. So all of the recipes are in Spanish. They sometimes have an in-house writer that writes the recipes, so it comes from a varied source of information. So I started with those recipes. I went to the archives and collected quite a bit of them. I'm going to show the numbers afterwards. But this is how my database basically looks like, the recipes that I have. And then this is how the image database looks like. I collected all the recipes, which again contains sponsored recipes, normal recipes, etc. I collected date and other sections of the magazine sometimes. But then I started saying, okay, I need to focus on what is the most important parts. So we look at the recipe text, the image, and the description sometimes, but I'm going to be just focusing on the actual recipe text, from which I'm going to extract the title, the ingredients, and the servings to end up with a structured database. How can somebody who's interested in doing this go about it? So you basically take the recipe, which is in a magazine, you make it into a digital image. You have these options available. I ended up mostly transcribing them myself, and I hired a small team of people who helped me transcribe some of them, 46% of them. So that's how I ended up with a structured database that contains a title, ingredients, and servings. So I have this source of information that I need to understand. So the methodology that I'm using is network science and historical research. So let's look at the descriptives of my recipe database. The year where there were the most published recipes was in 2001, when
Juan,
300 recipes. Go ahead.
Juan, I'm sorry, I don't know if you are not sharing the screen or the presentation or just because
Sorry,
we
something happened.
lose your presentation.
Oh,
Okay.
apologies for that.
Okay, perfect.
Sorry.
Yeah. Now we can see it.
Okay. So here is where we have the largest number of recipes published. And then around 2017 is the year with the lowest. So we see that there are trends here, but generally speaking, the magazine always publishes recipes. It started publishing in 1977. And then if we look at it, aggregating everything in a month, instead of looking at how many recipes were published each year, we can also see that there's some seasonality. So December, not surprising to me because it's a country with Catholic traditions, has most of the recipes published on average, where around 700 recipes were published in total for December. And here I have 40 Decembers. And then in May is also quite a high time for recipes. Again, we can see the Catholic tradition of Lent. So another metric that I looked at, which basically talks with more of the quantitative research, is we have here in the gray line the number of recipes that were published, and I'm accumulating them until I end up here with all of the recipes that were published, which is around 5,000. But then I look at how many ingredients are mentioned. So in total, there's a mention of close to 600 ingredients. So as we can see here, this huge jump, most of the ingredients, like close to 80%, are already mentioned in the first half of the circulation of these recipes. So there's kind of like a small space for inclusion of new ingredients, which is something quite interesting. I call this like discovery ingredients. Discovery basically goes down, it doesn't go down, but keeps stable after the beginning. Here, this is a heat map that has sorted the ingredient. So we can see if there's a color, it means that an ingredient was mentioned in that year. So the takeaway from here is that a couple of ingredients, very little, are actually mentioned a lot in recipes. So even almost in more than 120 recipes that year. And then most of the ingredients are very, very rarely mentioned. So most of the database is very sparse. So that's what we can do with descriptive statistics. But the power of network science is to analyze the connections between these ingredients. So let's take kind of a step to understand what is network science. Probably all of you are familiar with recipes on the internet, and I'm going to build a network with this. So you take the title of the recipe, and then you take the ingredients in that recipe, and then you connect them if they are mentioned. So you end up with something like this. You have a title, which is a recipe, which is calling for some ingredients. So we have here an example of 2 recipes. And then what you can do is to build a larger network where all of the recipes are connected to the ingredients that they mentioned. That's exactly what I did, but I connected 550 ingredients with almost 6,000 recipes. So we can see here, this is called a 2-mode network that has recipes. I have highlighted some examples here. Very typical soup from Bogota, the capital of Colombia. And I highlighted this one because it's a very typical recipe. And this one because it's the one that mentions the most ingredients. So that's how a network looks like. But then you can have all the network. You can have here in green the most frequent ingredients, and then I have highlighted here these recipes in the complete network. But this doesn't tell us much. This is what in network science is known as a spaghetti ball. Doesn't tell us much. So there are methods to extract the most important part of this network, and my focus here is in ingredients. So you can go from this 2-mode network to a 1-mode network where it shows ingredients connected to each other. How can you connect to ingredients? Well, by affiliation. If 2 ingredients are mentioned in the same recipe, then I can presume that they are usually paired together, so I connect them. So that's what I do here. I only have the most important ingredients here. And then I have colored them based on the category that they are representing. So here we have dairy products. Here we have like sweeteners. We have here minerals, etc. And here are some statistics of this network. So as in most quantitative research of recipes, most recipes mention around 8 to 9 ingredients. That's kind of the main component. It's very, very rare that a recipe mentions more than 15 or 20 ingredients. It will make it quite complicated to make. The other part is that, coming back to the heat map, most of the recipes, or most of the ingredients that appear in recipes, in fact, salt is the one that appears the most. It's very interesting that the water doesn't appear that much. But salt almost appears we have around 6,000 recipes, and salt is the number 1. This is sorted by frequency. So salt is mentioned in almost 3,000 recipes. So almost half of the recipes mention salt. Then the second one is pepper, etc. But it drops very, very rapidly. So more like a couple of ingredients account for a lot of the mentions, as it's kind of a trend. So this is a network that has all of the recipes. But how can we look at this from a historical perspective? What we do is that instead of feeding the whole database of recipes, I just feed it a sliding window, which basically says, I'm going to feed the network. Let's say that my sliding window is 1 year. So I feed it from 1977 to 1977 plus 1. And then I do this extraction, keep augmenting 1 year, and I feed it to build the network. I am going to show an example that I do with that for 5 years, and I am only highlighting the most important ingredients, so you can see how the network grows over time. So here we have from 1977 to 1982, and then we have salt, garlic, etc. Sugar hasn't even appeared here. Then I feed the next 5 years, so this is cumulative. And then I added these years, so sugar now appears here. And we're going to see how basically a world for sweet recipes and salty recipes start to form. Then I feed 5 more years, and then we can see egg whites, vanilla that appear here, and here um, in the salty part of the ingredients. We keep adding 5 more years each iteration, and then we have close to the network that I showed before. Again, I'm highlighting here the key ingredients. So this is basically how we end up with the whole network. This is a visualization that does that for all of the ingredients without just extracting the most important ones. I add here every year in basically, I accumulate every year here. So with those tools, then we can move into understanding category of recipes and understanding the changes after we have mapped this. So I am presenting here 2 cases. The first one is sweeteners. I'm quite interested in the role of sugar. So in the network that I created previously, I am highlighting here sugar, and we can see how from the beginning it starts growing. It's always very central. It's not an ingredient that sometimes it's not very widely used. What I'm going to do next is to compare the centrality. I mentioned centrality, which is a statistical metric for networks that tells you roughly how important an ingredient is in the network, how many connections it has, and how many connections pass through it. This is actually the algorithm that is used behind Google, that was published by the founders of Google back in 1992, if I remember correctly, to identify which are the most important pages in the internet. I use that to look at the most important ingredients in this network. So that algorithm is called PageRank. And here we can see historically the role of sugar. Since the beginning, sugar is one of the most important ingredients, and it continues being. But when you look closely, you can start seeing, and when you connect these to broader conversations on healthiness, on obesity that have happened in Colombia, you can start seeing how, interestingly, the role of other sweeteners is growing. Notably, we have here honey, which has grown. It's almost half as important as sugar as the most recent recipes. We have here sugarloaf, which is a less refined version of sugar that is known as panela in Colombia or piloncillo in Mexico. And we have even other sweeteners that are appearing. The other way to look at this is by accumulating this by month, and then see which are the months that use the most sweeteners. So, not surprisingly, December is also a month that uses a lot of sweeteners. A lot of Catholic traditions of connecting people happen with sugar, with desserts. October maybe has a lag, but it was surprised because it seemed that Halloween didn't make that much of a change there. But it's December where sweetness, conviviality, and Catholic celebrations happen. So the second case that I'm going to show is animal proteins, animal origin proteins. So this is quite interesting. There are actually more changes here. So beef is the one that appears the most in most recipes in the beginning of my study. But in the last 20 years, it seems that fish and seafood has grown in popularity. Beef and veal, and chicken is here. Interestingly, and this shows the bias of recipes. If you actually look at food consumption and sales in Colombia, chicken is number 1. But here is the aspirational effect of fish and seafood being the ones that are shown more. This gets more interesting when you look at it per year, because in Lent, a Catholic tradition, you're not supposed to eat meat 40 days before the Holy Friday. So the recipes substitute that for fish. And when you do the qualitative research, you can see that a lot of the recipes are mentioning fish and seafood for Lent. So that's why you see the peak here, which Lent tends to fall in March and April. The other interesting thing is Colombians don't really eat turkey for Thanksgiving like they do in the United States, but it is served in December. Sometimes it's kind of at the time that it's relatively similar to Thanksgiving. So you see the mention of turkey in November, December, never in other months, which is quite strange. So you also see beef and veal be mentioned less and being less important in this network. It's basically being substituted by fish and seafood during Lent. So you see this down here, and lamb is not even mentioned at all. Doesn't play a role in the network. So these are the two case studies that I have that I'm presenting here for brevity. In conclusion, taste does change. You just need to look at it, and it does change in long term, and it does change seasonally. And seasonally quite important here because Colombia does not have seasons, so it does change even based on these cultural seasons, or that basically have this Catholic tradition. So network analysis again is a food. It's network analysis of food recipes is a powerful tool to analyze large recipe data. I have around 6,000 food recipes that otherwise I wouldn't be able to analyze it. And this is the first network of Colombian recipes to my knowledge. So yeah, thank you so much. I open it to questions. If you have any, you feel free to contact me here as well in my email.
Thank you, Juan. Excellent presentation. Incredible work. I'm amazed. And a little scared about the dimensions of your work. It's really incredible. So now we are